So I want to get into section 7.3. And the idea of section 7.3 is we want to solve for x. Now, we've tried this before. We would do x plus 2 equals 5. And we would ask, well, what value would x have? Now, x again is an unknown number. So what number could x possibly be? Now, before, when we were dealing with x and y, we got to choose a number. And we could choose whatever we wanted. But now we've got to make sure we make a correct choice. X has to add up to 2 and give you 5. What number can you add to 2 to get 5? There's only one number. And that's when x is the same as 3. So we're going to get into some algebra. Now, what we want to talk about are opposite operators. And opposite operators undo something. So for example, let's start out with the number 10. And then we decide to add 2 to 10. And of course, that gives us 12. But then let's take 12 and subtract 2 from it. And what does that give us? 10. So we're back to where we started. So it turns out if you add 2 and then later subtract 2, well, where you started, you'll end up at the beginning. In a way, you could say adding 2 and subtracting 2 are opposites. They undo each other. So another way of thinking about this, we could write this a little simpler. Instead of all those steps, we could say if we add 2, which would give us 12, and then subtract 2, well, that would just keep us at 10. Adding 2, subtracting 2, these zero out, and we're just with 10. Likewise, if we do the following. Let's start out with 10. Now subtract 3. That gives us 7. Now take this 7 and add 3. That will give us 10. Right back to where we started. So subtraction has an opposite. It's addition. So subtraction is the opposite of addition, but addition is the opposite of subtraction. Or another way we could put this, 10 minus 3 plus 3, that just gives us 10. You lose 3, this will become 7, but then we add 3, we get back to 10. So these cancel out. So the idea is this: addition and subtraction are opposite operators. They cancel each other out. As long as you add and subtract by the same amount, add 2, then subtract 2, or subtract 3, then add 3, you start off right where, well, you go back to where you started. Now, let's consider multiplication and division. Let's say we take 10. And now we divide 10 by 2. Well, that gives us 5. But in the next step, we take 5 and we multiply by 2, and we're back to 10. So it turns out if we divide by 2, then multiply by 2, we get back to where we started. Or in other words, 10 divided by 2, then times 2. Well, 10 divided by 2 is 5. Then 5 times 2 is 10. We get back to where we started. Now let's consider the other direction. Suppose we have 10, and then we multiply by 2 to get 20. Then we take that 20 and we divide by 2 to get 10, and sure enough, we're back to where we started. So it turns out if you multiply by 2, then divide by 2, you get back to where you started. Or in other words, well, 10 times 2 is 20, then 20 divided by 2 becomes 10 again. So these cancel out. So what we get is that multiplication and division are opposite operators. So multiplying by 2 will be canceled by dividing by 2, just like dividing by 2 is canceled by multiplying by 2. And so the key thing about opposite operators they cancel each other out. So just to recap, 10 plus 2 minus 2 is still 10. What happens, these cancel out. 10 minus 2 plus 2, you get 10. They cancel out. 10 divided by 2 times 2 is 10. And let's try to switch pins here, because now we're working with another pair of operators. Those cancel out. And then 10 times 2 divided by 2 is 10. And those cancel out. So adding 2, subtracting 2, or subtracting 2, then adding 2, opposites, they're going to cancel. Division, multiplication, or multiplication, division, those also cancel. So that's the first part in working with our algebra. We're going to get to one more principle and then we'll solve some equations. Any questions, let me know.